Howdy, folks. Tuesday morning here with you. First, day seven. Today we're going to talk about interference and beats. We also got a couple practice problems for you. Don't forget we got a test on Friday. We'll lab you tomorrow. Sorry about that confusion. If there was any for you out there. Okay. So here we go. All right. Interference and sound waves. So, question for you is it so dumb to think that sound waves can interfere with each other? Meaning that, can we have a way for sound waves to interfere like water waves or light waves? Okay? Um, what would a constructive interference sound wave sound like? Um, Remember now, if we're talking constructive interference just means that you're going to meet same point, same point. When we showed that with a transverse wave or a standing wave, we saw that, when we get crest to crest or trough to trough, those two are going to join up and make it bigger, um, double the amplitude or whatever not necessarily double it, but make it larger, right? So when a constructive interference sound wave sounds like is, it's going to be louder, right? Destructive should be quieter, right? Again, for constructive interference to happen, it's crest to crest, trough, or I'm sorry, compression to compression, rarefaction to rarefaction. For destructive, it's compression to rarefaction. Okay? So imagine two identical sound waves coming from two different speakers. The two sound waves each have a wavelength of zero point 0.5 meters. What would you hear in your ear if you were the same distance from each speaker? Yeah, you'd hear that noise being very nice and loud. Okay? What if you placed one of the speakers so that it was 25 centimeters, which is 0.25 meters, closer to you? Well, now it's going to be quieter. It may not completely cancel it out, but it's going to be a lot quieter. All right. Again, because by just moving that half a wavelength, it's 180 degrees out of phase if you want to look at it that way from the previous note set. Okay. So, for example, if we got a speaker pumping out some sound like this, right? Now, if you go onto YouTube and you find sine tones, SINE tones, um, you can play those at a lot of different frequencies, and it's just a continuous, steady tone. And I'll talk more about that later, all right? But this is what the woofer or the component on the speaker does: is it basically creates a compressional wave like this. Okay? So what we see is these waves look pretty similar, other than one's blue, one's red. Right? So we ask the question: where are the loud spots? Where are the quiet spots? Right? So let me get some animation or some annotations going here, and let's see if we can find some loud spots. So loud spots are basically going to be the point where these cross together. All right, you got a loud spot there. Looks like you got a loud spot here, 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 here. Loud spot here, 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 and here. Right? Now, if you notice, these do track in a in a pretty straight line, right? The quiet spots here. Oh, let me change colors on you. Maybe make it a little easier. So here's a quiet spot. Here's a quiet spot. Quiet, 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 right? This one will be a quiet spot. Sorry. Quiet, quiet, quiet. Okay. So you'll also see a spot or a line or a area where there is this same feature, right? So if I continue to draw these out, you can see where all these quiet spots end up actually starting to happen for us. Okay. Um, so what we start to see is that we can do some stuff with interference, right? Sound waves produced from a tuning fork. All right. Now, tuning fork. Likely you do not have one of these, right? I've got a few here at my house. just for demonstrations or for labs or stuff like that. Okay. When we use this animation, what we're seeing is that the column of air between the middle of these two is going to get moved. It's going to get squeezed and expanded, squeezed and expanded, squeezed and expanded, right? So as that happens, what this is doing is these two are creating compression waves for us, all right? So as they create those compression waves, basically you're seeing that wave emanate out and through, okay? So you start to see where that area of compression is because it starts to move those molecules sideways, all right? So when we hit tuning fork, all right? Now you can't necessarily see that, right? But the nice thing about tuning forks is if you hit them easily, nice and easily, all of this is the top part that moves. If you hit them really hard on a very hard surface, like a piece of wood, like a table, like your desk at school, you all of a sudden hear this clang because everything now starts to really vibrate and shake, and you get this really big thing. What happens is they can break for us. Okay. Um, so they can get damaged. All right. So I'm gonna try this for you, okay? I'm gonna try and figure out where my speaker is, or where my microphone is. I think I got a pretty good idea, but I'm gonna try and rotate this. All right. So, oh, there was a clang. I hit it too hard on my elbow. Just rotating it. Now, I don't know if you could hear that or not, but what's happening is you get something like this. You get each tine on this, each part of this is going to have its own sound wave coming off of it. And so what we start to see is it starts to produce its own sound wave. I wish I could put these things in your hands, honestly, so that you could hear this because it is interesting. What happens is that when you do start to rotate it, you hear where they constructively interfere, and it sounds loud, um, and that becomes very obvious to you. Right? When you rotate it to another point, let's see if I there it's loud, there it's quiet. Okay. So the crazy thing is that then when you find a high and a low part, you make a quiet area. They start to cancel each other out. Okay. Um, with this, what we start to see is that this is similar to other interference that we've seen before. Okay. It just so happens to be with sound waves. So we start to see those compressions hitting those compressions, right? Okay. Again, map of high and low pressure areas in a tuning fork. Just showing you different kind of ways of seeing this, even though you can't really hear it very well right now. Okay. Um, beats. Now, beats are actually very interesting for us. The reason that beats are very interesting for us is because they happen when two notes are very close to each other and played at the same time. Now, after doing a little bit of research, it sounds like the number 7 hertz. Anything below that, we can hear it. Okay. So what that means is it's a pattern of repeating constructive and destructive interference. All right. Beats are insane. I'm not going to lie to you. These are absolutely just unbelievably weird to hear. All right. The application of beats is actually one that's somewhat interesting. I know, at least for me, it was. Um, if uh, if you're tuning a piano, and I would assume it would work for a guitar, what you do or what the piano technician does is they'll strike a specific tuning fork, or they'll play a tone off their phone, or whatever it may be, and then they'll hit the key. And what they'll listen for is that strain in the piano the same as the tuning fork. If it's not, what it does is it produces this wah 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 sound. I know that's really weird, right? But it produces that sound. Okay. And the reason for that is all of a sudden we start to see these two don't line up, right? If they're relatively close, like we see here, what we end up seeing is we end up seeing there's an area of constructive interference. That's where it gets loud. There's this area of destructive interference where now it gets quiet. Okay? So what we start to see is here the constructive interference is on the left-ish spot, right? Meaning that it's on that left side a little bit. Okay? The destructive, it's on the rightish side. All right. Now, if they're close enough, what you'll see is they'll actually meet up and then disappear. Meet up, disappear. Meet up, disappear. Meet up, disappear. Right. And so what happens is if we look at the resultant wave of this, we start to see pattern. Right. We start to see our constructive interference, and then it gets out to our destructive interference. Now, question for you. We heard how beats can be something that's important to our world. If we play piano or we play guitar, or we play another string instrument, right? But destructive interference. Now, if you're at a concert, you really don't want to be in a destructive interference spot. Or if you're in a movie or something like that, that's why they try to have all of that stuff, just be absorbed so you don't get the bouncing of those sound waves off of surfaces. Because imagine if you were at a or at a music show or a concert or something like that, and all of a sudden you were in this spot where all those sound waves hit, and all of a sudden the music that you heard was significantly softer or even almost canceled out. Right? That'd be terrible. That'd be a bad musical experience. But there is a real life application for this. And I imagine some of you have noise canceling headphones, right? And I know the new AirPods from Apple, they have that feature in there. Well, that's just creating destructive interference. What's happening is that it's analyzing your ambient environment. It's just listening to the outside. And what takes place is it actually will set a tone or set a sound wave so that it is just off 180 degrees. And what takes place is it's canceled out. Now imagine the applications of this. Imagine you're working construction, right? You're working with very loud machinery. Well, if you're not wearing ear protection, that loud machinery is going to cause your eardrums to eventually get beat up real bad, right? You're going to have loss of hearing. And now think if all of a sudden you can put a noise canceling headphone in there, right? And as you put that noise canceling headphone in there, you hear nothing. That's the beauty of those noise canceling headsets. Yeah. So what we see here with this is that we end up seeing, that this wave, this resultant wave, decreases. Now, as we allow those to go, yeah, they'll go back to being constructive, right? And then they'll go destructive, constructive, destructive. All right. If you want to hear beats, if you want to know what these things sound like, I invite you to do it because yesterday when I found it just put a smile on my face because it's really easy to do in class with a couple different tuning forks, but here in our houses, in our places where we're watching this, it's a lot tougher. So to find out how to do this, okay, we need them to be apparently separated by 7 hertz or less. That's where our hearing or our human perceptions kick in. Okay, so for me, I found 3 worked. And be sure go for it and try 2. Man, even try 1. I just wasn't able to find that in the little bit of research that I did there. Okay, so here's the YouTube channels you can go to. Right, and the way that you would do it is, and the way that I did it was on my computer. I played the 498. Right, on my phone I played the 495, and where my speakers are on my computer, I put the speaker on my phone right next to it, and I could immediately hear that wah 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 wah, that kind of wavering sound of constructive. Yeah, and it's kind of crazy. Either that, or ask a brother, sister, mom, or dad, or somebody else to say, "Hey, play this YouTube for me for just a second," and then play yours right next to it and just hear it because it is trippy. It is very weird. Okay. All right. Here's some practice problems that I got for you. All right. Just again to make sure that we're doing okay with the math components of this. So go ahead, give these a shot. Basically, try and get the answers correct what I'll do is I'll put up work for them if you can't get them right. Um, but for us today, this is what I want you to work on. This is what I want you to try. All right. You will not be turning these in. These are on your honor to help you stay current and continue to feel good about the math stuff for Friday's test. All right. So at this point, I'll encourage you to probably pause this so that you can look at these and have a good feeling about how to run this. All right. Otherwise, that's what I got for you for the day. Hope you have a great day. Take care. We'll see you tomorrow.